Alright, in this video we're going to talk about comparing two means. So we're going to do a two-sample t-test. Our hypotheses for our null hypothesis can say that the mean of the first sample is equal to the mean of the second, or you can write it as the mean of the first sample minus the mean of the second is equal to 0, whichever one you're more comfortable with. Our alternative hypothesis would be that the mean of the first is less than, greater than, or not equal to the mean of the second. It could also be written as mu1 minus mu2 is less than, greater than, or not equal to 0. Alright, conditions. So we're just going to double the one sample conditions. So I need to have two independent random samples. The population for the first sample has to be greater than or equal to 10 times the sample size for the first sample. And the population for the second sample has to be greater than or equal to 10 times the sample size for the second sample. And we have to have two normal populations, or N1 and N2 both have to be greater than or equal to 30. If the conditions are met, we're going to say that we're using a t-distribution and that we're going to do a two-sample t-test. Make sure that when you do your conditions, you define what 1 and 2 are. Okay? So the mechanics to find our test statistic, it's going to be your statistic minus your parameter divided by the standard deviation. So it's going to be x bar 1 minus x bar 2 divided by the square root of the standard deviation of 1 squared over n plus the standard deviation of 2 squared over n. And then we can calculate the p-value. Okay, so when we do the p-value, it's going to be using a t-CDF. Okay, and the probability that t is less than or greater than your test statistic, the t-value that you found. And then remember, if it's a not equal to, you have to multiply that probability by 2. The degrees of freedom will usually be calculated on your calculator. When you do the test, it'll give you the degrees of freedom value. But if you are doing it all manually, then use the smaller degrees of freedom out of the two samples. Alright, so on the calculator, what you would do is you would go to Stat, Test, and then option 4, which is a two-sample t-test. Then you have the option, again, to either use data. So if they give you a list of data values, you put it in list 1 and you use the data. Or stats. If they give you a bunch of the stats, they give you the means, the standard deviations, the sample sizes for the two samples, and you would plug it in there. If you get the t-value and you want to find your p-value, then you're going to go to second, vars. You're going to go to t-CDF. You're going to put in your lower bound, your upper bound, and your degrees of freedom. Your conclusion, it's going to be the same two sentences that we're used to. So we either reject or we fail to reject the null hypothesis, and we have sufficient or insufficient evidence to support the alternative. Make sure that that last sentence is in context. Alright, so let's look at an example. Resting pulse rates for a random sample of 26 smokers had a mean of 80 beats per minute and a standard deviation of 5 beats per minute. Among 32 randomly chosen non-smokers, the mean and standard deviation were 74 and 6 beats per minute. Both of the data were roughly symmetric and had no outliers. Is there evidence of a difference in mean pulse rate between smokers and non-smokers? Okay, so I'm going to write my hypotheses. So the mean of smokers is equal to the mean of non-smokers. That's my null hypothesis. My alternative is that the mean of smokers is not equal to the mean of non-smokers. And we're saying S is the beats per minute of smokers and N is the beats per minute of non-smokers. So they told us that the number of smokers that they sampled was 26. The mean for smokers was 80. The standard deviation for smokers was 5. These are all in beats per minute. The sample size for non-smokers was 32, with a mean of 74 and a standard deviation of 6. So they gave us stats. That's what we're going to plug in when we put it in our calculator. So we're going to check our conditions. So I have to have 2 random independent samples. Well, they stated that both of the samples were were random, and we assume that smokers and non-smokers are independent of each other. Number 2, the population has to be greater than or equal to 10 times the sample for both samples. So we assume that there are more than 260 smokers and 320 non-smokers. And number 3, normality. Both sets of data are roughly symmetric, and therefore the population is assumed to be normal. So they told us that it was roughly symmetric with no outliers. So we can use that as our meeting the condition. So conditions are met, we're using a t-distribution, and we're going to do a 2-sample t-test. So I'm going to put this all into my calculator, and I'm going to write it all the pieces in my formula. So when you put it in your calculator, you're going to get all the pieces you need. You already have the 80, the 74, the 5, the 26, the 6, and the 32 to plug into your formula. So you can do that and calculate the t-value, or you can plug it on your calculator, get the t-value and the p-value and the degrees of freedom all at the same time. Your calculator tells you that degrees of freedom is 55.953, which is about 56. To find the p-value, it was a not equal to, so it's 2 times the probability that t is greater than 4.154, which equals 1.129 times 10 to the negative 4th. That value I got directly from my calculator. The 4.154 I got directly from my calculator. And the degrees of freedom I got directly from my calculator. All I did was write the formula so that I had something to show as work. So now I can state my conclusion. Well, our p-value was quite small, so we reject the null hypothesis because our p-value was less than our alpha value of 0.05. We have sufficient evidence that the average pulse rate of smokers is not equal to the average pulse rate of non-smokers. Remember, we're talking about averages and means, so you need to have average or mean in your conclusion. Alright, what would a type 1 error in this situation be? That would be if we are concluding that the pulse rates of smokers and non-smokers are different when they are really equal. A type 2 error would be that if we were concluding the pulse rates of smokers and non-smokers are not different when they really are different. And power, remember that's a good one, is the probability of concluding that the pulse rates of smokers and non-smokers are different and being correct. Alright, a 2-sample t interval. It's going to follow the same conditions as a 2-sample t test. Once our conditions are met, we're going to use a t-distribution and do a 2-sample t interval. Our formula is going to be our statistic plus or minus our critical value times the standard deviation of the statistic. So it's going to be x bar 1 minus x bar 2 plus or minus t star times the standard deviation, which is the square root of sample 1, the standard deviation of sample 1 squared over n for sample 1, plus the standard deviation for sample 2 squared divided by the sample size for sample 2. That'll give us our 2 values, which will tell me the difference between the 2 groups. Okay, so on the calculator it's going to be a stat, then test, then 2-sample t interval. Again, you're going to have the option to either put in data. If they give you data, you put that into list 1 first. Or if you have stats, then you go to the stats command and you fill in all the stats that you have. If you calculate t, or if you need to calculate t star, your critical value, you're going to go to second vars inverse t. Then you're going to put the area only on one side of the tail or 2 sides of the tail, depending on what kind of interval you're doing. Okay, so typically it'll be just the one side. And then your degrees of freedom, which you're going to have hopefully by doing the test already. Usually you'll do both things together, or you might have to do the interval, get the degrees of freedom, then go back and get your t star value. Alright, So our conclusion is going to be basically the same. We are blank % confident that the average of group 1 is between blank and blank units, higher or lower than the average of group 2. Or we can state it like this. We are blank % confident that the difference between the average of averages of group 1 and group 2 is between blank and blank units. Okay, but make sure that you don't say the average difference. So it's the difference between the averages, the difference between the means, not the average difference. Okay. All right, so this example, we're going to create a 95% confidence interval for our previous example with smokers and non-smokers. Well, we already checked the conditions, so we're going to just state that the conditions were met. We're using a t-distribution, and we're doing a 2-sample t-interval. Our mechanics. Okay, I would plug everything I have into my calculator at this point, and I'm just going to fill in all the pieces that I get from the calculator. So I knew the mean of the both pieces. I knew the standard deviations and the sample sizes. I had to find t star by doing inverse t, so second vars, inverse t, putting in the area, and putting in the degrees of freedom, which was about 56. And that gives me 3.1063 to 8.8937. Degrees of freedom was 55.953. All right, so everything we can get, we can calculate. And remember, if you don't want to actually calculate t star, you can write t star and then subscript your degrees of freedom. So t star subscript 56, if you don't want to have that extra step. Our conclusion is we are 95% confident that the difference between the averages, the average pulse rate of smokers and non-smokers, is between 3.1063 beats per minute and 8.8937 beats per minute. So, example 2. Here are the saturated fat contents in grams for several pizzas sold by 2 national chains. Do the 2 pizza chains have significantly different mean saturated fat content? If so, complete an interval to estimate the difference. So, first I'm going to do a test. So I'm going to set up my test, and if they are very different, I'm going to do an interval to figure out what the difference is. So, my null hypothesis is that the mean of brand D is equal to the mean of brand PJ. Okay, and then remember D stands for brand D saturated fat, and PJ stands for brand PJ saturated fat. The alternative is that they're not equal to each other. Their means are not equal. My conditions, I'm going to assume random. Okay, so I'm going to assume that the samples are representative of the population because it didn't say that they were taken from a random sample. At least I didn't see it. So, and we assume that the brands are independent. The second is the 10% condition. There are more than 200 brand D pizzas and more than 150 brand PJ pizzas. Normal probability plots of both are approximately normal. So what we would do is we would put all the data values for brand D in list 1, all the data values for brand PJ in list 2. We would do a normal probability plot, and we would have a rough sketch. And then if they're both linear or approximately linear, then we can say both normal probability plots are approximately normal. So once the conditions are met, we're doing a t-distribution and a 2-sample t-test. Okay. If you run the test in your calculator, you'll get all the important information that you need. So run the test first, get all your data values, then plug it in and show that you have some work. So I found that the sample size for brand D was 20. The sample mean for brand D was 11.25, And the sample standard deviation for brand D was 3.193. The sample size for brand PJ was 15. The sample mean for PJ was 6.53. And the sample standard deviation for PJ was 2.588. The degrees of freedom that was given in my calculator was 32.757, which is approximately 33. So now I can plug this into the formula, which is x bar 1 minus x bar 2 over the square root. The whole thing is under the square root. Standard deviation of 1 squared divided by n plus the standard deviation of the second squared divided by n. So I have all those pieces. I'm just going to plug them into the formula. And then my calculator told me that the t-value was 4.823. I don't have to actually plug that all back into my calculator. Okay, so I'm just taking all the values from my calculator, plugging them into the formula to show as work, and then writing my t-value. The p-value was also given in the calculator. Okay, but to show the work is 2, because it's not equal to, 2 times the probability that t is greater than 4.823, which gives me 0.0000315, which is quite small. So our conclusion would be we reject the null hypothesis because our p-value of 0.00003 is less than our alpha of 0.05. We have sufficient evidence that our average saturated fat content for brand D is not equal to the average saturated fat content of brand PJ. Okay, so we really could have gone on and done a confidence interval to see what the difference between the averages is. So we'll do that in class. And then your turn problems are page 579, number 2, 3, 11, 14, 27, and 36.